Okay, class. Good morning. Let's have another problem for angular measurements. For this time, we'll have the close traverse. Okay, close traverse. From the previous example, that is open traverse. Okay. So for this one, the problem you have from the closed compass traverse shown, if the forward bearing of line AB, you have line AB, is north 62 degrees 15 minutes east, compute the following. Forward bearing, so this is the forward bearing. The azimuth from north, okay, only the azimuth from north, and the deflection angle of the line. Okay, so you are given the tabulation. So you need to fill up the data. Okay, so but we are given in the problem the forward bearing of line AB. Okay, so we have the forward bearing of line AB, this one, forward bearing, so that is 62 15 minutes. This is north and east. So for the bearing here, we have the given. For the bearing, you have north 62 degrees 15 minutes east. And then next we have the forward bearing of line BC, this one. So the given for line BC is the interior angle of line AB and C. So but we know that we have the forward bearing of line AB. So for this angle, that is just equivalent to this angle. Okay, so for this angle, so let's extend it. So this angle is just equivalent to the bearing of line AB. This is the backward bearing of line AB. Okay, so we are given an interior angle, therefore to solve for the bearing for line BC, this is now the bearing for line BC, this one. So bearing for line BC is equal to, so you have the interior angle minus the backward bearing of BC, BA or AB. So that is 125 degrees 40 minutes minus 62 degrees 15. Okay, let's have a calculator. Okay, so we have 125 degrees 40 minutes minus 62 degrees 15 minutes. So we now have 63 degrees 25 minutes. That is from north, by the way, that is south to east. Okay, so we have 63 25. So south, 63 degrees, 25 minutes east. Okay, so next we have the bearing for line CD. Okay, so for the bearing of line CD, that is this one. That is the acute angle. By the way, bearing is the acute angle from the reference meridian. So the reference meridian, you have the vertical line. This is the reference meridian. So therefore, for the forward bearing of line CD, that is this one, extend from, okay, this is bearing CD. So to solve for that, we already have the forward bearing of line BC. So therefore, you have this backward bearing of line BC. This is 63 degrees 25. Okay, so to solve for that, this one, to solve for the bearing CD, you have for this one, this is 180 degrees for straight line. So you add 158 degrees 35 minutes plus 63 degrees 25 minutes. Okay, you add this minus 180 degrees. So that's the bearing for line BC. We just based our solution from our illustration or from our drawing, since for this straight line, this is 180. So for the total, this one, that is just the backward bearing of line BC and the interior angle. So you just deduct 180 degrees. Okay, so to solve for that, you have 63 degrees 25 minutes plus 158 degrees 35 minutes minus 180 degrees. So you have 42 degrees 0 minutes, and that is from south to east. Okay, so let's have that in our table. So that is 42 degrees south, 42 degrees east. South, 42 degrees 0 minutes east. Okay, next we have the bearing for line DE. Okay, so for the bearing, we start with the reference meridian to the line. So not this one, since this is an obtuse angle, we will have the acute angle for our bearing. So we'll extend this line, and then we'll have the bearing DE. Okay, so to solve for that, this one, this is just a one quadrant. So one quadrant is equal to 90 degrees. So therefore, you have 90 degrees minus this angle. Okay, to solve for bearing DE. Okay, so to solve for that, that is 90 degrees minus 30 minutes at minus 30 degrees 15 minutes. So that is equivalent to 59 degrees 45 minutes. And that is from south to west. Okay, so you have now your forward bearing for line DE. That is 59:45. So you have south 59 degrees 45 minutes west. And then last for the bearing tabulation. So you have bearing EA. Bearing EA. So from the given, we have already the bearing or bearing angle. So that is from the reference meridian to the line. So therefore, you just have to add the direction for the bearing. So for the direction, that is north and west. Okay, so you have your bearing north 38 degrees 10 minutes west. Okay, so that is the bearing of the lines for the compass traverse. Next, we have the azimuth from north. So for the azimuth from north, for example, this is the north, east, southwest. So we have the azimuth from north. So we start always from the north, and it is always clockwise direction from north. Okay, for the azimuth, clockwise direction from north. So for line AB, that is also forward azimuth from north. So for line AB, the azimuth starts from north. So this is the azimuth. That is the same, 62 degrees 15 minutes. Okay, so we'll have our azimuth equivalent to 62 degrees 15 minutes. Then next, we have line BC. So for line BC, you have your azimuth from north. So that is from north to the line BC. Okay, so to solve for that, for one quadrant, that is 90 degrees. And then for this one, we have the bearing, and for this quadrant, that is 90. So we will solve for this angle. Okay, so to solve for that angle, you can have 90 degrees minus the bearing, and then you add that to 90, or you can have the 180, the straight line or the reference meridian, 180 minus the bearing. Okay, so you can have that also. So for the calculation, let's have the 180 degrees minus the bearing of BC, 63 degrees 25 minutes. So our azimuth from north is, for line BC, is 116 degrees 35 minutes. Okay, so let's put that in our tabulation. That is 116 degrees, 35 minutes. Okay, and then next we have the azimuth from north of line CD. Okay, so this is line CD. Azimuth from north is from north to line CD. Okay, so that is the azimuth. So from north to line CD. Okay, so to solve for that, you can have, to solve for this angle, you can have the 180 degrees for the reference meridian, 180 minus the bearing. Okay, or you can have 90 degrees minus this bearing plus 90 degrees. So it's up to you how you solve the angle. It's just based on the drawing. So in any case, you can have your own solution. At least we come up with the same answer. Okay, so to solve for that, I will have the 180 degrees minus the bearing. Okay, so therefore 180 degrees minus 42 degrees. Therefore, the azimuth from north of line CD is 138 degrees. Okay, so you have in the tabulation 138 degrees. Next, we have the azimuth from north. So this is now our north. Let's extend that north. Then going to line DE. Okay, so to solve for that, you have the reference meridian, that is 180. So straight line is 180 degrees plus the bearing. Okay, from the reference meridian going to this line DE, you have 180 degrees plus the bearing, forward bearing. So to solve for that, you have 180 degrees plus 59 degrees 45 minutes. So you have 239 degrees 45 minutes. Okay, so you have 239 degrees 45 minutes. Then last, for the azimuth from north, you have, so this is your north. So for the azimuth from north, that is clockwise direction. So that is from north, or reference meridian from north going to line EA. So therefore, for one cycle, that is 360 minus the bearing, which is 38 degrees 10. So calculate 360 degrees minus 38 degrees 10 minutes. Okay, so that is equivalent to 321 degrees 50 minutes. Okay, so 321 degrees 50 minutes. Next, we have the deflection angle. So for the deflection angle, I already discussed the definition. By the way, deflection angle is the prolongation of the preceding line and the succeeding line. So for example, this is the preceding line. So you just extend this line, and then the angle between that line and the next line is the deflection angle. Okay, so we just extend that, and then you have to measure that angle or that line from the preceding line to the next line. Okay, so let's have deflection angle of line AB and BC. So we will extend this line, and then we have this angle. Okay, so this is the deflection angle. This is our deflection angle. So from the extension of line AB and line to line BC. Okay, so to solve for that, for this straight line, this is 180. For straight line, that is equivalent to 180 degrees. So to solve for that, you have already 180 degrees. Then you have the interior angle. So therefore, that is 180 degrees minus 125 degrees 40 minutes. So that's the deflection angle. Okay, to solve for that, you have 180 degrees minus 125 degrees 40 minutes. So you have your deflection angle equal to 54 degrees 20 minutes. Okay, so 54 degrees 20 minutes. Okay, so next we have the deflection angle of line BC and line CD. Okay, so we just extend the preceding line. So extend line BC, and then the angle formed in that is the deflection angle. Okay, so this is now your deflection angle. So the extension of line BC to line CD. Okay, extend. So this is now the deflection. So to solve for that, the same, you have this 180 degrees for straight line, and you have your interior angle. So therefore, you have straight line, that is 180. So to solve for this angle, you just deduct the interior angle, 158 degrees 35. To solve for that, that is 180 degrees minus 158 degrees 35 minutes. Okay, so you have 21 degrees 25 minutes. Okay, 21 degrees 25 minutes. So next you have line CD and line DE. So for line CD, you just extend that, and then the forming angle from line CD to line DE, that is the deflection angle. Okay, so we'll extend extend this line, extend line CD, and then we have the angle. So for this angle, that's the same. You have 180 for straight line. So we'll have to compute for this angle. So 180. So you have 180, and then this is the deflection angle. To solve for this, you have this bearing 42, so therefore this bearing also so your drawing is very important in this kind of problem, so that you can trace the angles. It's just equivalent to that one. So therefore you have this line. Okay, you have this line that is 180. So to this line, okay, so therefore to solve for this this angle, you have the bearing that is just equivalent to this one. Okay, so this angle here is also equivalent to 42. Okay, okay, so that is, I don't know the term in trigonometry for angle in opposite sides. I think complementary angles. So that's the same angle to the other side. Okay, so that is 42 degrees also. So to solve for that, you have this straight line. So let me redraw it. So let me redraw to a bigger. Okay, so you have your line BC. This is a CD, line CD. Okay, and then you have the bearing, this one. This is 42 degrees. So if you extend this, so this is also 42 degrees. Okay, and then we will solve for this line DE. So you have the deflection angle is from this one, from the elongation or from the extension of line CD, extend, and then this one. But we all know that the azimuth from north of line DE is 239 degrees 45 minutes. Okay, so from this drawing, I think we can solve now the deflection angle. Okay, for this one. So deflection angle for line CDE. Okay, so to solve for that, we have the straight line that is 180. So straight line 180 degrees. to solve for this, we have the total angle from line CD is 1. Okay, total angle minus this, or you can have the total minus this one. By the way, for this angle, this is given, which is equivalent to 30 degrees 15 minutes. Okay, so to solve for the deflection angle for line CDE, you have from this line going to this one, okay, minus this one. No, you are to solve just this one, the deflection. So if you have your reference from line CD going to this line, okay, so this is 180 minus this one. So therefore, you have the solution. So based from the given, you are to solve for the deflection. So you have the 180. So you can have 239 degrees 45 minutes plus 42 degrees. Okay, so that is from this line going to that line. Okay, and this is 180. So therefore, you have to deduct 180 and this angle. Okay, since you have the total angle for that one, then minus 180 and minus this one, so the remaining angle is the deflection angle. Okay, if you have another solution for this, you can have that, as long as we have the same answer. Okay, so minus 30 degrees 15 minutes. So therefore, you have this one. Calculate 239 degrees 45 minutes plus 42 degrees minus 180 degrees minus 30 degrees 15 minutes. Okay, so you have 71 degrees 30. Okay, so let's put that in our tabulation. We have 71 degrees 30 minutes. And then lastly, you have the deflection angle of line DEA. So extend line DEA, extend this one, and then you have your deflection angle. Deflection angle. Okay, so we have the bearing for this one. We have the forward bearing of line DE, which is 59 degrees 45 minutes. So therefore, you can solve directly. This is 180 degrees straight line minus 59 and minus 38. So you can have this angle. So that is 180 degrees minus 59 degrees 45 minutes minus 38 degrees 10 minutes. So you have 82 degrees 5 minutes. Okay, so you have this one, 82 degrees 5 minutes. Okay, so for the tabulation, you have all the answers.